Hello, good evening. All right. Hello, Christian. Hello, Artem. I prepared everything, I hope, today. Hey, Sonic. I just went down the stairs and checked out in the basement one of my old part boxes where I disassembled something, and I found some optics of an old camcorder, and I hope there inside will be, oh wow, maybe even here. Is this from a camera? I will check for a concave lens that we can put in front of our device. Oh, what? It's still waiting to start. Guten Abend. Oh, there's more to that. Look at that cute thing. This is a high voltage power supply. I'm probably charging for the flashlight here. Here, there's a flashlight. Yeah, so this was a photo camera. The new plan is blisters. You have blisters from that, or you got some. Do you have scars from? Hey Jones, hey Johnny, hey Adam, hello Deshipo, hello Carsten. So the plan for today. Last time we were successfully testing this pink LEDs. Maybe you have to stay on all the time to find out. I let in some fresh air. I had my pocket coffee already, so I should be fresh. I need to crack this open, this lens. So what we saw last time is the thing successfully drawing on. Yeah, I can still show it. Let's show again what we had last time. I hope I didn't destroy anything in the meantime. Hey, Artem. Alright, so let's show again the last state that we had. Oh man, so annoying. Okay, my phone was still so annoying. Okay, where is it? Yeah, we just replaced everything. I mean, we replaced the driver circuit here, and we made this amplifying circuit last time as well, which is also powered by the power supply that was included in the listing of the Galvo. So here is the Galvo setup. We're using a weak red laser for the testing, so there is no persistence displaying for now. And I will just plug in my phone, and the phone signal, which is 1 volt, will be amplified to, what is this, 5 volts or whatever, and projected here on the screen. If I can, come on, where is it? Aussie music. Maybe we can use, come on. Okay. I plug it in and we see what happens. Oh yeah, we need the power supply. Let me turn off the light. Oh shit, wait. I need to turn off that. And this needs to be... okay. This is what we should see, and this is what we get. You probably can't hear it, but there is also audio. So, I mean, the audio is coming out of the galvos that are going crazy back here. Here. Oh, the mirror is a little bit dusty. We might be able to get a better focus. So this is the current state of the device. I like the extent, maybe of X and Y. X maybe not enough. We can still tweak it a little bit. Yeah, tuning in X. We can widen it. That's Y direction. Oh wow! We don't need the lens. Okay. Let's do X. Okay, we don't need the lens. Sorry, chat was in the way. The only thing that I need to take care of is the heating of that. Yeah, that's probably the range, because you have like the trimmers that you can still... Okay, it's getting hot now. So we need a solution for the heatsink. Yeah, and when it starts to smell, it's no good. So at 15 volts, yeah, we need something to cool this down. And you have the okay, that's hot to the touch. It's hot to the touch. We can check with the camera. With the fondue cam, we will check at the same time. Wait. Alright. Active cooling fan. Yeah, these are glowing. What's the maximum? 69 degrees. Yeah, I think also. With some heat pipes. But it looks like... You know what it looks like to me? The heat isn't well distributed. Oh! Whoa! But that's 40 degrees. The galvos are 40 degrees. They might also need some flow. Crazy. Okay. Yeah, so I don't know. Maybe it's reflective, yeah. Yeah, it's reflective. The drivers? Oh, okay. The transmission, the galvos, I don't know. It's 15 volts. It's delivered with this power supply. So it looks like the aluminium block isn't hot, but actually it is. It's just reflecting the other heat. So yeah, that's, maybe I should record this. Let me video that. I get the stamp of my finger. That's funny. So hard to use 3 cameras at the same time. Okay, so when I put my finger over the holes, drilling holes of the aluminium block, I get the holes in my finger. Yeah. No, that's alright. I mean, if it's like hot to the touch, then you know it's 50 degrees. Apparently, I mean, we could use still a lens to use lower voltage or less current on the galvos, so the galvos won't overheat. But then I need a concave lens, so we would need to open that up. Yeah, we will find a way to cool that. It's so hot. Hey Arun! My son Max is learning for a German test, but he can't remember Philos. Can you help him? Philos, it's a lot going on here. Hey TMK. Okay, so I will crack this old lens open and we will see if we can. Galvos are really hot to the touch. Maybe we can we disassemble it somehow? Oh, there are screws, so maybe. And I should be able. Let me. By the way, who mentioned that I might get a copyright strike? Sonic, was it you? Did you make? Someone was right about the copyright strike. I didn't know that, like, that was protected in some way, but nothing serious. I just can't monetize my the Austin music, and it seems to be copyrighted in such a way that I can't monetize my stream. But that's alright, I'm not earning much of the stream anyway, so I sacrifice for the greater good and leave it in. Yeah. Yeah, I will so I will just take money from the pink LED fund for the two euros that I miss from my income. Okay, I have smaller screwdriver. It's getting so hot in here. Yeah, but I think it's not like claimed for themselves, so it isn't serious. If it was like someone's claiming the income from the stream for themselves, then I would just mute it for the part. You can basically, as a simple action, you can just tell YouTube to mute the track there, and that's it. Or you can replace it with something else, I believe. So there are some actions that you can take for that. But it was, I think it could be only like the L.A.S.E.R music, the original video. Not like, what is, there's Iris. Yes, copyright. With Rick Astley, yeah. Plus 11, yeah, same here. But it's getting colder again. I hope it stays warm. I don't like the cold. It costs money. Oh wait, there is a screw that I missed. That will probably disassemble the whole. Yeah, here we go. Interesting. This is just protective glass. Or maybe that's an IR filter now. I believe it's just. Interesting. Okay. We will just take it apart. Yeah, and the trees are blooming. I hope not that that the trees won't be freezing this year, because last year I didn't get a single apple because of the frost in May. It got quite like was it end of March, was quite warm, and we got some blooming quite early, and then end of June or beginning of May there was like 3 freezing nights, and everything died. So we didn't have any apples. Oh, there is a small motor. Look at that. I like liquid snow. Yeah. That is a lens that I'm taking apart to get a concave lens for the laser. Maybe we can run it less hot, and the galvo, if we can use the lens to spread it less precision, but also something's breaking. Oh, this could be used for a galvo, because I think this might be a solenoid as well. Can I take it apart without breaking? That's an old camera. The camera isn't existent anymore. It's a basic photo camera. Yeah, here we go. Interesting. It's just, oh wow, look at that. $20 frames per second. Yeah. Nice shutter. Nice shutter, bro. Here we go. Let's cut it off. Shit, lost a few screws. I don't need the screws anymore. Anyways, here we go. Ah. This will go into my solenoid / whatever drawer, motor drawer. Oh wow. Huh? Uh-oh. I might have... Okay, this is the mechanic. This is so cool. Here is another one. Oh yeah, that's the lens. Yeah, we can't. Let's use it this way around. No. Okay. Is there? You think there is a concave lens? Can't be only. Can't be just convex ones. But this will be hard. I guess they're already quite small. I would love to see that one. There is a screw. Assembly falls apart. Shutter mechanism is cool. It's so tiny. Yeah. Okay, we have still this thing. We might need to remove this pin here. Okay, here we go. Whoop! Whoop! Nice. Okay, that's the shutter. That's the lens assembly. Wait, there are 2 more screws. Let's not drop it. Oh, I dropped already screws underneath my driver board. Should be more careful. But it seems not very expensive camera since the lenses. Yeah, but that was probably an analog camera anyways. Oh yes, here we go. There it is. Can it? Come on, focus. No, it's too heavy. That's the concave lens that we wanted. There is a convex one. So stain. Manual focus. Oh, and there is another cool concave lens. So we have this one is looks good. Okay, so maybe we can use that for the laser and drive it less powerful. Okay, let me plug it in. Oh, blah, 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 blah. No power, no strike. No, I'm okay. So, very strong. Too strong, no good. Okay, let's use less power, like that. And then add the lens. Here is the lens in front of it. But then it's defocused again. I like the effect though. Okay, we're not adding any optics. I rather drive it hot. Let's observe how hot they're getting now, if the galvos get hot or not. If I run it a little bit lower, $37, $39. Power supply. The diode on the power supply runs at 50. And there is a resistor, which is also hot in the power supply. Oh, 95. Okay. So the drivers were like 95 degrees. Let me show that again. Maybe they are still hot. $76 still. Yeah. Yeah. 76 degrees. Okay, we need more cooling. So this needs to be addressed as we speak. The aluminum block gets okay. How do we add this heatsink here? I have different heat sinks that we can use, but let me turn the lights on and the laser off. Boop, boop. Rated to 150C, the drivers, okay. Plastic ties? What? What? You mean the heatsink? Yeah. Yeah, just submerge. We submerge it in. Liquid nitrogen. Okay, this will be not enough. This will be also not enough. I think this one still has a fan, but I don't think this will be good enough. Yeah, this is just a too small area. We rather need that. That was probably from AMD or whatever. I really don't want to drill a hole in this nice heatsink, but it would fit nicely. White mountains? Yeah, we had snow here as well. Okay, can we... Oh, I can get zapped by this driver as well. Can we put both drivers, like the power supply... Yeah. I know that. Yeah, no, this is not... This won't work. This won't work. I don't want to do this. I can still run it at 12 volts, not 50. Thermal paste. Oh, we can use like a clip or something. A clip, but I would just drill a hole there. But there are heat pipes everywhere, so no drilling. Thermal glue. I don't have thermal glue. I don't have thermal glue. When I put thermal paste on that, this will be a huge mess. I have different kinds of pastes. I think, nah, 2 types. I think this will be the same. How old is this? So crusty. Lid doesn't open. Yeah, it's separated. The oil separated from the paste already. What kind of clip can we use here? Or we can use bolts and just need something on the other side. There is, yeah, we could put some wire or something in here. Welding wire would be nice, but this is in the workshop. Coat hanger is an option. What clamp? Klebeklemme. Ah, es ist eine Klebeklemme. Binder clips. Oh, yeah, binder clips would be nice. Rickard, how did you do it? Schwarze Aktenklammer. Hey, Mayor. Leimklemme. Ich habe keine Aktenklammern. Oh, lime klemme. Okay, okay. You mean something like these here? These are like plastic. That might be good enough, but I want more permanent. Spot welding. copper to aluminium. Good luck with that. Does that work? Copper and aluminium? I don't think so. Look at that. The plant died. That was ejecting the flies, the fruit flies. Chopstick and took a piece of cord that was thin and strong. Yeah, I think I will use welding wire. I will just grab some welding wire, but I have to leave you here alone. And I'm scared that you do bad stuff here while I'm gone. Okay. I think I will grab some welding wire. So, I'll be back in a second. All right. What did I miss? Look at that. This is... I have aluminum welding wire, which will be perfect just for bending it around. Cable binders. Yeah, but they will melt. Oh wait, I could short stuff if I use that. Oh. Okay. There are also move that around like that. So I have some more space to work with. Or do I let me just this detach it shortly. There we go. Oh no! I can't short those things. They are insulated. These are like two different channels. Oh, that was almost, I almost killed my device again. Yeah, I can't tap the screws in the fan. Maybe the heat pipes are far enough apart here. Now, shoot. Okay, let's remove it, otherwise it will short it. Can we tap it somewhere here? I will add a new hole. Now, should I just take a cable tie and we are gone? We are done. Ain't nobody got time for that. I don't have a cable tie that's long enough. Not in the fan. There is, look at that. That are heat pipes. They are filled with stuff that will escape when we drill into that. We can't do this, but we can use several cable ties to secure it temporarily. Yeah, no, that's probably methane or something. I don't know. Could be. The cable. Oh wait, across the bar. No. I will use this serious cable tie. Hey Caspar. We are trying to improve our cooling solution of the driver. Yeah, temporary forever solution. Fine. Temporary / final. Just need to get it. I want the cable tie to be tied with and square with the caps are too close to the heatsink. Yeah, I know. The caps are free. They are free to go. Aye. I think this is alright. Now we need the paste here. Shit. I shouldn't have tightened it before I put on the paste. Now we need to take it down. The caps are that draws some power. It got very hot, so what's going on? Oh wait, this is done! I need more. $40. Okay. Yeah, you need to dissipate that. Okay, I have more. Stir it. I should record a little bit. Ah! Okay. This stuff will be everywhere. Alright. I don't have any tissues in my lab anymore. Oh! Shoot. Okay. Yeah, here we go. Here we go. We have no fan yet. Let's see if 40 watts passive cooling is alright. I mean, piece of art, yeah. Let's see if we can, yeah, we can use that. Yikes. Bloop. And okay, let's put it back. I will try to find a tissue, paper tissue. No, it's not epoxy. Okay. Now, let's attach it again. Nice. That's good news. $300 views, not bad. A little bit messy everything here. I would need to. Which misfit? What? Mirror. This, oh, MOSFET. Yeah. Maybe it's a misfit. Okay, think it's just oh yeah. Okay. I don't know what it's playing, but it's certainly mono. Oh, interesting. Yeah. Yeah, the noise is coming from the galvos. Okay, now X and Y is flipped. So I need to flip it again. Can I check what power it's drawing? I can. I might be able to see. No, they're like. Okay. One thing at a time. I want to see the thermals. Shelly. Yeah. Okay, we have 41 so far. Let me record that. We are running at running it with this passive cooling, and it's at 43 degrees. So actually this is 24 degrees. Yeah, 24. Okay, I think we have a temporarily. Oh, these are warmer. No, 40 degrees. No, 30 degrees, sorry. Yeah. Driver is now at 50. The power supply is interesting. Interestingly, on the power supply, and I can show that easily. Maybe I can show that like. You can see the hotspot in the center. That's a resistor and a diode. I can smell something. Maybe. Okay, drivers are at 45 degrees, so the heatsink is working. It's 26 degrees now. It will be probably. Oh, that's warm. It will probably be enough to passively cool that thing to run forever. I would be more worried about the galvos, which are at 36 now. Yeah. So we need some active cooling inside, maybe a fan or whatever. Okay. Here we go. Let's unplug it and discuss further steps. Cooling solution, check. Still checks with hand, yeah. If it would show 70 or whatever, I wouldn't touch it. Maybe I would touch. I mean, we need like the... We need the content for the video. Okay, let's turn on lights again. With the power of Home Assistant. Boo, bow. But this one is so loud. I need a passive one. Passive power supply there. Because of my project contribution to L.A.S.E.R, I got a coupon for $100 for L.A.S.E.R shop, and I had like the passively cooled power supply in my cart, because passively cooled power supplies are good for if you're a content creator. And then I think it was there for a month or something, and then the coupon expired. What? They give me as payment, they give me a coupon which expires? Seriously? Ah. Yeah. It was, yeah, they don't, L.A.S.E.R is not a big money company. They have to come by. Anyways, what's next? Let's get MS Paint. I need a new case for that. If I want to print a case for this whole device with this huge heatsink, some active fan cooling, for the galvos, so I can just let it run on the Maker Faire or whatever. But I was surprised. I thought like the galvos are rated to be like plus minus 15 degrees, and that's enough to fill the whole screen here. So it will not expire now? Ah, cool. That's cool. Okay, MS Paint, and let's do the work. Okay, switch. Here we go. So now we have what? This is like preamp. Dust on mirrors, you're right. So we need like a filter, and filter will be great for also stray laser. Because if I want to take it to the Maker Faire, I don't want like to cause people to go blind. So we have a preamp. We need some sort like ESP. and this is driver. Driver, and then Galvo. Galvo. Okay. ESP. Now Sonic mentioned something that might be interesting here. We have the problem. Okay, this on its own is great. I mean, this is already a project. Just needs a case. I don't know how to fit all that stuff in there. It will grow for sure in size. But what we have right now is this. Let me clone. This is our audio amp, a preamp, and the issue right now is we have a capacitor. So Sonic, I think I thought about it, and I think Sonic is right. We have usually a cap here. Oh, fucking keyboard is always switching to German. I need to restart to disable that because I already changed the registry. There is no way in stupid Windows to disable the English language for the keyboard without removing it completely. But I don't want to remove the English language. Can you reduce the drive voltage to them? Yes, I could reduce it using a different power supply. Using 12 volts. But then I probably won't be able to cover the whole extent of the screen. I'm not sure. Maybe if it we can run it on 12 volts as well. You remove Windows. Yeah, no. All right. So what we have is we have this here, the audio coming in, preamp, and if we want to rest, let me open a new paint. Can I open just a new instance? Yeah, I can open new instance. Okay, so English language. If I record something for my videos or whatever, I want usually the UI to be in English. Also, I think it might be that I need for something like the calculator, if I copy paste, German is always written with comma instead of the dot, the fractional part, and that's a difference. You can only like change the language to Canadian English or whatever if you don't want messed up date format. Yeah, there are some. They changed it. They changed it. Like usually there was like languages that you could remove from the keyboard, but they put everything combined in the regional settings now. And no matter what you do, what I do, especially, whenever I switch the application, it just switches the keyboard or whatever. I don't know. It seems like if an application is set to English, it will switch to they. Why? Why? It's a physical keyboard. I know for an on-screen keyboard that might be true. Yeah. It's strange. And what nice fact is to not have like messed up like imperial formats and values and date format and whatnot. I mean, Canadian is still using like switched order of month and day in the date format, but you can change it to ISO format, where you have year, month, day, which is a nice compromise, and the files sort better that way. But I always, if I use switch something to English, I use Canadian English to not have to deal with the imperial units. All right, let's talk about what we wanted to do. So Sonic mentioned we have now, let's say, input to our driver which represents the position on the screen. So it's like this. So this draws maybe lines or square on the screen. You have two signals. So something, I don't know, this would jump from one position to another position, more or less. This is the audio signal. But the issue is to oh. Ah, shit. Why is the... Okay, here we go. So this is, if we use like coordinates or dex or whatever, this is like max value, this is time, whatever, t, this is voltage, this is 0, this is 3.3, or let's say 3 volts for the ESP, and this will be basically deck values, no? And what we can do is we need at some times we need to rest the voltage at a certain level, but this is like DC voltage, so this is DC realm. Direct current and alternating, and we need, like, since our Galvo works in plus minus realm, we need a capacitor in between to decouple it and have AC. And we would expect it to look like that. Wait, what? Yeah, this is the ESP. Yeah, that's the issue is usually this is driver. So the driver works in AC unless you want to use only like one side of our display or whatever. Then you can stick like to the DC. But you want like to use the full range. It can do DC, you can use DC, but then you will lose this whole negative area. You will still be able to draw like that if you input that directly. Minus DC. How do you get minus DC? That's AC then. Bye bye, Dutch. Okay, so yeah, there is something about that. Okay. Yes, that's the issue. You need like the area. Okay, let's talk about it. So if we use maybe talking about DC and AC is confusing here. But if we use like the simplest way to convert, like to shift it to negative here, would be using a capacitor, which is used always in audio circuits to decouple from the DC signal, to decouple it and have it to swing around zero or common ground or whatever. There is no zero actually. So maybe that's also misleading. So let's remove that, because we only know the capacitor. There is no ground anymore. We have some ground in the driver, but let's forget about that. So there is no connection to ground anywhere. What happens then is we have. This will basically balance around a virtual zero where the areas cancel out. Or we should do. So the sum of. Shit, what is here red? This is brown. This area, this area, this area, this area. If we add this is, or subtract this, will be the zero. Polytool. Oh, you can see the zero. So basically, this is our new zero, and the issue now is. If we zoom in on, let's say, this region, and we stay at a level, let's say this looks like that, for a long time, oops. For a long time, what will happen is this capacitor here would charge up. And then what happens is, yeah, our zero level will basically go down like that. Or let's say like this is our new zero level. It will move like that. And this whole curve, if we, yeah, what we will see is like that. So this is the transfer. So if it will rest, this will happen. And this is because of the capacitor, which is charging up. So either you take a big capacitor, but then I don't know if it's AC couple DC. Yeah, remove the cap. Okay. But okay. What is simple about that? That's so many components. Voltage clean. Oh, that's Chris? Okay. SPI? But what did he do? How do I shift? Okay, here. Yeah. Yeah, we can shift this maybe. Or I show you a different solution that I might have in. Hey Rota! Don't you usually control the voltage? It swings around by. A weak pull-up. I don't know, Rota. I have no clue. I'm not an expert. Summing amp to level shift. Yeah, unskew it. Unskew it and just do it. Just do it in software. But the issue is if you do it in software. I mean, you can do it. You can split your lines basically in segments that are equally distributed between positive and negative, or what I would do, that the software hack for that is you spend majority of your time drawing a black frame, maybe even out of your view, so the capacitor is pulled like have a weak voltage divider that puts half VCC to an ADC. Then couple any AC to it. How do you couple it? Okay, let's take a look at the circuit from Chris. Maybe we will be VREF. Okay, this is positive, negative. We have a voltage divider here. What is L plus? What is that? Where is the V out A, V out B? Oh, this is. He's using an audio amp, but this is. I think this is the audio. Where is the? Oh wait, no, that's the DAC. Laser driver. That's the laser. Unused op amps, output drivers. Left, right, plus, minus. Oh, wait. R minus, R plus. Huh? We're trying to find out. Yeah, we would need. Okay. So he apparently has like plus minus here, and we are tied to ILDA. What is ILDA? In the past, I drove a laser card like yours from a sound card. Yeah. Hey, Konstantin. Yeah, we can do this, but we get like issues with this with the AC decoupling, where it starts like to long like squares. Plus minus levels. But we have only like L and R. There is no separation between those on our driver. We just get positive, negative. You soldered the sound card before the cap. Ah, okay. Okay. So, my idea is way simpler than that. But it won't work with this power supply. I tell you what the idea would be. Okay, either we do a DC shift. What we can do is basically keep no cap, and we just do op-amp magic, and have a DC shift. Oh shoot. A DC shift here. DC shift. So from 0 to 5 to minus, yeah, something like that. Or let's say, I mean, we have a preamp. We can still keep the preamp here and do this basically from 0 to 3 to minus 1.5, sorry for the comma, to 1.5 volt. Shit. How do I? Let's do the plus minus. Minus plus. So it's like that. Summing amp. Yeah, level shift and input with a summing amp. So let's do that. Hashtag lab. Oh, that's like ages ago. Where is it? Too bad I don't read my own Discord. Okay. Here we go. Okay, here we go. Open in browser. By the way, that was one of my first videos. Sound card DC. What is? Oh, that's a trimmer. Oh, this is basically a buffer. Buffer for the voltage. And then you have, oh, this is how you add the voltage. Wait. Yes. This is the divider. You need this to limit the voltage because this is a buffer. Okay, I understand this part. What is the sub out plus out negative amplified, positive amplified? What? Yeah, but we don't have this. We have only like one line. This is what we need is basically shifting the signal beforehand. Oh, thank you for the follow. Negative galvos like my second one. Ah, right. What does that do? Oh yeah, that's just inverting. Oh, so this is basically a differential input. Why don't you say that's a differential input? That's just inverting the signal. Oh, you did? Okay. You just did. Maybe I missed it before. Yeah, that's basically differential to have maybe the fast signal be better transferred or processed. Noise reduction. Yeah. That's also, if you have like all this stuff going on, noise reduction might be good here. All right. So now what we want to do is I just want this here, this part. I want a positive signal we can center that. Okay, let's see. Let's do a new window. Or let's do it here still. So what I will steal from your drawing is basically what we can do now is we use the trimmer to get, this is this is 15 minus 15, and we have the trimmer here, volts, then oh really? This is how that works? Tech? No, we need some component there. So what we would steal here is this part. Here's DAC. This is plus, minus, like that. Oh no, wait. We affect the output signal as well. So we do it like this is higher. No. This is terrible. I don't like that. Our voltage will affect this signal directly as well because we have a direct path here. How do we do it? Two inputs. Huh? Two resistors to the same input. Dutch. Yeah, this is what we have here. This is what we drew. No. Wait. What? Why am I so tired? Wait, no. Non-inverting summing amplifier. Summing junction. Wait, what? Oh, and this is like the... Oh, wait. What we can do is, yeah, this is the volt, but this needs to be the same. Wait. Okay, let's remove that part. This part is good. Simulating, if you tell me how. Okay, peeps, this is it. We need DAC. here. We need buffers on both sides. If you tell me how it's working, like that, and here, this is the circuit what we want. We have both inputs buffered, so same impedance, same. This is R and this is R. Is this decoupled? I don't know. What? Isn't that right? No, I don't know. Should work. They're not added. What's happening? They averaged. No, that's average. Okay, how do I do LT spice? Yeah, but this is, I think this will always have the average it. They are summing. No, we have, they're averaging. So if this is minus 15, and this is, let's say, 0, then this will be minus 7.5. So it's not summing. That should be minus 15. My circuit is bad. Buffers are always good. Yeah, no. This isn't it. Okay. How do I download it? Is there LT Spice in KiCad? How do we simulate that? How does it work? Is there LT Spice online? Differential amplifier circuit. Oh yeah, that's adding. No, they're not adding the signal. It's inverting. Differential amplifier is inverting one input and then adding. But it's adding. Okay, yeah. Let's check out. Okay. Hey Ray. Zero V. Why virtual ground? Oh wait. No. Will I need goggles? Maybe. Yeah. Yeah, it's both same current here. That's like they are pulling a rope both. This one wants to pull the rope towards minus 15. This one wants to pull it towards 0. And that one peaks at this point here and sees, oh, that's minus 7 point. Yeah. Okay. Okay, what do we have here? While we are still down, what is this? Yeah, this has virtual ground. This is... Oh, okay. Circuit lab. Don't need to download it. Where is... No, these are the gates. A book? No, I'm not reading books. $30. Wait, can we have differential? We have negative voltage step. How do I do? Minus. Ah! Here we go. $60. That's the ADC side. Wait. ADC output. Yeah, but this is this is why we buffer. Can we add this? How do we add? Add wire, add... Huh? I want to add an op amp. Let's stop it. Differential amp is pretty simple. You just need some resistors. PWM to inverting and offset voltage into inverting, non-inverting, generate offset voltage from voltage divider. Doesn't need to be buffered necessarily. Yes, doesn't need. Actually, if you put like a resistor in front of that, so what you would need is, I don't know how to. Virtual earth. What does that mean? Virtual earth. Summing point. How does that work? That's 0. Oh yeah, this is the negative. Ah, yeah, but we have an actual ground. The ground we pull it to is the one that we want from our voltage divider. And if we use a voltage divider, then this basically... How does it work? Yeah, I will put a buffer in between, because if we divide the voltage, you know what? We should watch a video about how to do it properly from a person who is very competent about this. We just need to scroll down 10 years. To find the right thing. Oh, wait a second. Decouple. Where's the electret microphone thing? Is this the one? No. No. That's not. I made a video. I know I made a video on exactly what we are doing right now. Cooling cap. We will decouple everything. I tell you, we will not decouple it. That's a simple. Where is my video? I made a video on that. No. Shoot. That's not it. Can't find it anymore. It is frustrating, yeah. Okay, forget it. Bitluni doesn't have. How do I what? Input upset voltage. some phone decalcifications in my head. Okay, this will work, but oh wait. This is all right. This is minus 7.5, but if we do 3.3 volts, it just pulls minus 7.5 volts downwards. So half the voltage that we are setting here. But that's all right. If we lose like, it's all wrong. No, this is all right. This is this is perfect. Okay, let me extend this. Boop. Why do I need inverting? Why? Why inverting? L.A.S.E.R. So let's calculate it. This is the average. If we get 0 from DAC minus 15 will be the two input interact. That's all right. Half the amplitude. Yeah, it halves the amplitude. But let's calculate. Tiny URL. Oh. Wait, what? What? What black magic is that? You have plus and input. This is different, not sum. No, I'm not summing anything. I'm just doing the sum here. If we have both resistors, the resistor is basically the voltage here. Peeps. I'm confused. Can we... Yeah, this is... this is... How and why? What kind of black magic is this? Wait. I love that solution because it's so simple. What are the settings? Max voltage DC offset. Wow. Can we show output? Wait. Scopes. I want to see that one. Show. How do I show it? Down there. Huh? Huh? How do I edit? View in new scope. Oh, here. Yeah, no, this is correct. Okay, I wouldn't use 1K here. I would use 10K. Can we change this to 10K, please? Because I don't want like for it to be crazy. This is sick. That's like 4 parts. And it's doing what it's supposed to do. L.A.S.E.R. But the op-amp floats on the output. Yeah, but this is alright. If this one floats, we will just buffer it. If we need to. And we have a dual op-amp here. Change the last op-amp to inverting. Here. You mean like... Inverting, you mean like... L.A.S.E.R, can you explain why? I mean, I would, what you want to do is, wait, this will be ground. Ah, fuck, here, ground, this is plus, that, no, why that, why do you invert this? Yeah, that's all right. The web circuit, we have plus minus. What we have here, okay, let me check here. That's all right. We have the voltages. Oh, all right. This makes sense. And we can even amplify that. That's like already the signal. If we make like I'm only wondering, this could be sketchy. If we replace those two by trimmers, no. Let's compare this one with this one here. No, this is the wrong one. This one here. And this one can... Yeah. Yeah, that's I would like to be able to trim that, you know. So I know we could replace just one by a trimmer already. And then I'm checking if you replace, this is output. I'm wondering if you can, if this circuit if you flip that to the side, this is our voltage. It's negative. Can we switch that? Can we rotate that? It's basically the same thing, just upside down. No, it's not, because we don't have like the Yeah, what does that say? I mean, we looked at this circuit already. That's that. I like this this. Wait, which resistor? Yes, it's just. Oh wait, does this one change anything? Wait, this doesn't change anything. Can we just remove this? This is just annoying. So this could be a trimmer. Does it matter? No, we need, because that's 3.3 volts. Otherwise we don't get it inverted. That's all right. The 3.3 volts, this is the signal we need, because our input voltage is 3.3 volts. We want to shift by something in between that. This is minus. We're subtracting 3.3 volts, a portion of 3.3 volts. What's happening here? How do I rotate this? Oh, I just do that. Okay. So what's happening here? Oh, come on, wire. Wire, W. What, how do I add wire? Shoot. Add wire, W. Huh? Oh, yeah, okay. So this is what's happening. Very simple. We subtract half the voltage, 3.3 volts. I mean, Let's flip it. That's confusing. Wait. No, I don't want... Now I just want to edit this. What? Plus... Yeah, he's late. It's tired. Hey, Dave. This is triggering. This is triggering everyone. This needs to be clipped into a video. Rota, this is perfect. I don't want to change anything about this. Yeah. How do you make the... Yeah, no, this needs to be 10K. Rota. Otherwise, I like it. Because we're burning some current here if we don't use 10K. That's alright. Yeah, this is the same. This is basically identical. You can see, oh, maybe you can see on, but between minus 1.5 and plus 1.5. How do we scope it? Wait. It's the same. It's identical. Oh, here we go. Oh, that's perfectly fine. I mean, you have just the divider feedback, and then and you have here. The only thing that is worse about this, we need more components, because that one needs only this trimmer here. No, the scope was there. It was just out of view. Add some caps. We just need one trim pot here, and we can shift it around. Look at this. If we do like 10K, boop. What happens if we do 0 here? What's... What happens if we do 0K here? Boop! Patient death. $10. 10K. Wait, what happens if we do 100? It's clipped. It's clipped. It's only, the only issue is it's halved, but this is alright, because we have 3.3 volts plus minus 1.6, and we expect plus minus 0.5 input for preamp. I like this. It looks odd, but it's alright. And if we switch it, let's, how do I move? Edit, no, draw. Select and drag. Okay. Here. That's not how power source works. Power source always does its stuff. Here we go. Ah! Oh, wait. This is now adding. Wait. It's adding. Wait, when I flip, nothing happens. I like the sim. Ah! Why just cursed circuit? I like the Rota's idea of making the people cry. It's dead now. Something's off. Oh no, it was just off. Where I connect a live cat in. Yeah. Schrödinger's amplifier. Troll stream. What we can do is we switch this to minus, so you're happy. No, it's dead, Jin. It's dead. Now it's flowing only this direction. Why though? Alright, I give up. The only thing I know is that I like that we get here our DC signal in, and all this is running on the op-amp side. That's a simple trimmer where you can just adjust it and be good. One trimmer, one op-amp. Hot chip and lie. Let me check if we have space for another chip on our board. No, we don't. Damn. You can't just adjust it, changes the gain. Yeah, but we have like... Yeah, I know. It changes the gain. That's alright, but then it's constant. What do we have here? Minus 15. Oh! That's not bad. $10K, $10K, $100K. L.A.S.E.R, but where do we add our trimmer to adjust the shift? This will be the trimmer then here. Does this stay? Yeah, that's perfect. But if we replace this part with a trimmer, can we shift it around? But this stays 100K, and this around the same. The 100K. If we have a 100K trimmer, that would be ideal here. Instead of those two resistors, we have a trimmer where you can basically subtract anything. Do I see it right? Yeah, we need to buffer that. That's sure. That's clear. Let me try to give the 100K input. Oh yeah, we need that so we don't get minus 15 volts into the deck. No, wait. Trim the other 100K. Why? I want to understand. No, I don't like criticize you. I just want to understand why. Why we should... I would think that the ratio between this and the sum of these here has to be like similar. So if we take a 100K trim pot here, and that it will... No? Why? Please explain. Let's simulate it. Let's edit here. Can we copy that? Yes, ha ha ha. We copied it. Ah. Oh wait. The input voltage. Okay. Okay, let's see. Let's copy. I copy paste. I will just add the 3. So here in comparison, wait, 100K. We'll just draw it here. I like this tool. It's looking. Wait, this was 10K. Crickets. I admire analog crickets too. Wire. Boom. Wait. No, yeah, I don't want to draw wire. Okay, I want to shift it like that. Okay. That was tied to ground. Do we have ground? Cursed. It will be cursed. Fool. Yeah. Nah. Yeah. Flip. And then oh yeah, here, wait, this was wrong. Shit, sorry. V to minus 15, wait, yes, this was wrong, sorry. It's the first time I'm using this tool, so please don't judge me. It's clipped here. Now it's not clipped. That's what I meant. This here is the trimmer sum of 100K, same ratio. If we put it to 100K, what I'm wondering is, on your simulation, LT-Spice, it's not. Maybe this tool isn't precise, but it's clipping here. Let's put it to 200. So if we put this to 20 and this to 10, I mean 80 and 20, no, it's completely off. What? No, it's plus minus gain 100K. Something's off. Why do we need 90K here? Maybe the gain is too high. Let's use this. Max is 49. What happens if we do that? That's the gain. Too much smoke. $10K and $100K is the gain. This is shifted. But why do we get, like, why is LT-Spice a different output? This looks like perfectly on plus minus 15 here. Yeah, I get that. Perhaps losses for all the RGB. Oh, wait. 1.3 point. Oh, yeah. 3 volts. Yeah, no. That's the issue. We have 3.3 volts. What is actually, it's actually 3.3 volts. So we have that input, but we can so 19.2K 19.2, or that gain. It doesn't show the min and max values. Max scale, combine properties. I don't see that. Scopes. Combine. Interesting property. Show spectrum. Auto max gain. Show peak. Show negative peak value. Yeah. Okay. So we have a dominant negative shift here. Was it 3? What's the common 80K, 97, 60K? But this will be what you said, the trimmer here. 100K trimmer. What happens if we do 0 here? Does it short? Does it break? No, we have high values here. We can do a gain and shift. I don't want to rewire the amp that we made. It would be so cool to have the gain and the shift of the input signal in one place. So this would be gain. Yeah, we can't do those two trimmers. Potentiometers. How do we do that? Draw. Passive components. Where's the potential? How do I add this? You know what's bad? I can't copy that URL now because this is running in OBS. Click and drag. Oh. So many links. But I like it. I like it. I like it, Picasso. Roter? Was ist das? Roter? Oh, you made it. Aha. How do I shift it? How do I change the value? How do I change the value of the device? Oh. Patient death. I just need to check so we don't get bad vibes coming in here somewhere. Gain. Rota, I think you take the cake. Lasse, thank you for explaining everything. Oh. Why? Why isn't that a good circuit? Please explain. I want to learn. Tech. Too many parts, everything. No, it doesn't. I mean, this is perfectly... This is like the virtual ground for that. It's setting... It's setting... wait a second. It's just setting the value that we are aiming for. To subtract. It's the shift. This is the gain. And this is the shift. This is like an input voltage. Is it mirror though? No. Analog front-end design people. I like the controversy because we have so much interaction. What? It's inverting? Roter. Roter. What have you done? This is inverting. Uh-oh. Change the way to sawtooth. Yeah. It's still inverting. I didn't change anything. You check the lines here, look at that. Output, input. Always a cold solution. Where's my signal? No, this is clipping. 3.3. Yeah, this is just... Oh, that's a good thing. Wait. You know, peeps. Yeah. It's 15 volts now. I lost it. I can't flip the op amp to be non-inverting. Yeah, I would need to feedback it. A different way. What I don't like about it is that we have potentially minus 15 going this way. No, what hurts me right now, I guess we can handle that inverting in software, like we do it live, mirror everything. But what hurts me is if we have minus 15 here and your blood pressure can't take anymore. L.A.S.E.R, let's talk about it. Okay, so we have the issue now. Circuit is powering up. This is set to input. And then this op amp can potentially output minus 15. Okay, there is 100k, 100k in between, but we have like 100k minus 15 volts potentially on the pin of our microcontroller. So we could put in like a protection diode here. Yeah, I wouldn't buffer it in that case because if we buffer it, that's all right. Yeah, okay, I know. L.A.S.E.R, don't be so agitated. The solution is the same. Look at this. If we power this up, this is potentially minus 15 volts, which is going directly into the... We need to buffer it anyways. So I like the solution here as well, but it has the same problem that we are handling. Like I want this to be isolated. So we would need to put a buffer in between here. So if I copy that, it's no. Whoopala. Short circuit. It's run it. Singular matrix. What? Oh wait. Visual smoke. That was wrong, sorry. My fault. Ah, this needs to go there. Here. This is what we certainly want a buffer in between to not send negative vibes. And a protection diode here. Yeah, if we fry the op amp, then it's alright. But yeah, this is what we need. Same, but the same is with Rota's circuit. Here. Oh shit. Diode will distort the signal. No, it won't. I show you what I mean. Where is it? Shoot, I lost it. You can't take it anymore. I think I lost my windows. Where is the open window here? Fuck. I lost it. No, here it is. Okay, so I show you what I mean with diode won't disturb and passive components. Where is it? Resistor. Where's the diode? Is this... Diode is an active component? Ah! I didn't know that. Okay. Ah! Oh, half active. Why is out2 broken now? Because of the diode? Oh. What's going on? I lost it here. Wait, was it 100k? Yeah, it was 100. Okay, here we go. Okay. It's still shifted. I mean, it's minus 15 plus 13. So it needs a different value. And this will be the protection diode. Just it just prevents negative current. It will just short any negative current to ground. If it would happen. How do I store that? Export as link. Short URL. Okay. So, peeps, this is my solution for you. Are there any rates to do? I think we can solder that next time. I'm sorry we didn't get any further. Or I will just order a simple circuit. Hoffman is live. Okay. Can you rate? No, I don't need it. I won't build it in. I'm just scared. I just don't want to fry things. And this is the other one. This is rotor. Again, boop, boop. Okay, Twitch. I'm done for today. I'm quite tired. People. Why? Why do you think we should build both and see what happens? Put an actual scope. Few milliamps. Yeah. It's, I don't know, there is like the internal diode but 10k. I mean, it's 100k across, so that would be all right. If we buffer it, then you don't know what happens within the op amp. That could be more than 100k. So actually might be smart to not buffer it, but I really don't want to have any negative voltage there. So either we buffer it or we put in the diode. Or put in the diode and the buffer and the trimmer. Anyways, let's do the rate and I'll be gone for today. Rate, oh come on, rate channel, who's there? Following. Oh, you know what? We have... Hoffman got so many rates from us. We can do JV peak. Okay, let's go there. Start rate. Output impedance. All right, bye everyone. It was a nice nice stream. I learned a lot, and see you next time. Okay, JV Peak is German. Enjoy. Bye bye everyone.